Thank you very much, Lawrence Graf, for your reply and support. Actually, I also believe the same that EH is independent from the operating system, and the operating system is living in the PXI controller, whereas EH is living on the FPGA. EH is not reason for your issue. Yes, I agree on this. Uh, all the parameters, everything, including primary uh, control loop parameters, is same. Let me show you and repeat the results. You see, right now, these are the results. I will not be changing these initial parameters. These will be kept same. The circuit would be kept same. Only I will burn the controller different for the Linux and uh, different for the I mean second PXI file lib. Now at this time, it's working fine. It's working in file lib. Let me quickly show you. Configure. Please have a look. This PXI, which has 192.168.10.41 IP address, in this system, PXI file lib is installed. So currently, it's running in the file lib. Let me show you here. It's working in the file lib. Controller is simulation model. This bidirectional boost controller is working. I will not be changing the parameters for this bidirectional boost control. Please note this thing. Uh, I mean, these are the inputs value. These values will be kept same for both the cases, FARLAP and Linux RT. All right. Please have a look at results. It's working fine in closed loop. When I change it to 200, it will switch to 200, and duty cycle will be 50%. All right. And when I change to 150 volt, it will take to new uh, a closed loop DC boost controller. It will follow the reference voltage. This is the value of proportional, this is the value of integral, this is ramp rate. And if I set it to manual mode, in manual mode it's also working fine. If I make duty cycle 40, accordingly output voltage changes. Everything is working fine, both in manual and closed loop. All right. Now I won't change these parameters. Uh, Now let's move to when I shift from this PXI to another PXI, which is this one .16, which is running in Linux. Let's show results for that. I disconnect and deploy it. I go to configure. Now the other has the address of 16, so I go to controller and make the IP address 16. I check from here Linux x64. You see these primary control loop timing sources, other parameters, I do not vary them. They are kept the same. But now this simulation model which was running, it's a DLL file. But as we know that the Linux requires .so file and not .dll file. Therefore, I delete this bidirectional boost controller. Instead of DLL file, now I'm taking instead of DLL file, I'm taking .so file. Nothing else I am changing because it requires .so file now for Linux. I load it. I press OK. Now you see, these are the inputs, outputs. Well, I will be keeping the same values of inputs and outputs. I won't change the values. Please note, if I load it, I want to confirm if these values are changing. Let me remove and recheck. Decimation is 1, rate hertz is 100, simulation model processor is automatic. Let me take a screenshot of this one. If these model setting values are changing. Okay, I delete it. I add simulation model. I add DLL file. I click OK. 100 automate. These settings are same, so hence verified. So I again load .dll here, sorry .so here, for just for my verification purpose. All right. So I have loaded .so file here. Okay. Controller is .16 Linux x64. Every parameter is same. The parameters have not changed. Let's save it. Okay. One thing that I need to uh, correct now is mapping PWM generator 0 and my Y04 DC link is connected with the Vout process. This was also before, the same setting was before. Vout process. Connect. Okay. All right. Let's save it and let's run it. Now I have shifted from far lab to NI Linux and into another PXI. Now please note I will keep these parameters same. These parameters will be kept same. It's about to finish. Target synchronization is complete. I give it same 100 volt here, 200 volt here. Ramp rate is same 1000. P out value is same 0.008 as before, minus 0.192 as before. Duty cycle 50% manual as before. When I select to mode 1, it's working fine. So in manual mode, it gives desired results fine, no issues. But when I move from, I mean, from manual to automatic mode, now this problem happens. Now you see the V out process is not giving the correct values for the same controller. I don't know why. If I make the uh, if I change its value IV out to duty cycle to 0.005, does it work? Let's have a look. Now this is the problem. This is the issue. I don't understand why the difference is coming when the same controller is working in Linux. I need your help on this. Thank you.